Hello my dear students, once again welcome to your online class. Today we'll be discussing about the combination of pulleys. So in the last video we discussed about a single movable pulley and a single fixed pulley. Each of them had its own advantage and disadvantage. In case of a single fixed pulley, we see that it just helps us to change the direction, but whereas it does not act as a force multiplier. And in case of a single movable pulley, it acts as a force multiplier, but one of the disadvantages is you require to pull or apply the effort upward. So now we can overcome both of these defects or the demerits by combining both of the pulleys together. So today we will see how do we obtain the maximum amount of force by using the combination of one fixed pulley and several other movable pulleys. So in your exam you will be asked to draw a diagram of the combination of 4 movable pulleys with one fixed pulley. So let us try to draw and as well as derive its mechanical advantage and the velocity ratio. Okay, so I make a diagram like this. Okay, so I'll combine the 4 movable pulley with one fixed pulley. So what do? I draw along the first must be a longer one. Okay, so I draw one movable pulley here. Okay, and the end of this I take it little bit upward, and this is the axis, and let the load be supported here. So let the load L be here. Okay, so at the end of this, what will I do? I'll draw another movable pulley. Okay, such that the end of this rope goes to the axis of the second pulley. Okay, so this is how we draw, and then another rope comes and support this pulley. So again the end of this road I draw another movable pulley here. Okay, so this is the axis, so the end of this rope goes to the axis of the third pulley. So now finally I need to draw one more of the movable pulley, so I draw it here. Again one rope and the axis like this. Okay, so now finally the end of this, now since if I do not fix here one movable pulley, I have to apply the load, the effort upward. So for convenience, what they do, I connect one movable pulley here. Okay, so there I have one fixed pulley, the axis being here. Okay, so that I can apply the effort downward. Okay, so let L be the effort and let E be the effort required to raise this load. So we know that the tension on both the sides of the pulleys, they are always the same. So let the tension on the first string be T1. Let on the second it be T2. On the third let it be T3. And on the last let it be T4. Now what will be here? Since the tension on both the sides of the pulleys must be same, so here also it will be T4. Okay, so let us try to find the mechanical advantage of this system. So we have the mechanical advantage is equals to load by effort. Okay, so from this figure what do we see? We see that now the load is supported by how many T1s? The load is supported by 2 T1s. So the load is equals to 2 T1. Okay, so that means this 2 T1 is supported by 2 T2. Okay, so what can I do? I can do this one as now again. Now if I need to find this T1 is supported by T2. So again T1 is equals to 2 T2. So what will I do? I'll substitute the value of this T1 in the first equation. So therefore I get now L will be equals to 2. Now T1 means it is 2 T2. Okay, so now again, now from the figure this T2 is supported by 2 T3. Again we have T2 is equals to 2 T3. Now I'll put the value of T2 in the previous equation again. So again L will be equals to 2 into 2. Now T2 means it is 2 into T3. Now again we have Again this T3 is supported by 2T4. So we have T3 is equals to 2T4. Again I substitute the value of T3 in the previous equation. So therefore finally I get load will be equals to 2 into 2 into 2. Now the value of T3 from here again it is into 2T4. So finally I get the load will be equals to 2 to the 4, 4 to the 8, 8 to the 16 T4. So that is what is the expression for the load. Now coming to the effort. So from the figure we see that the effort is supported by 1 T4, so it is T4. So therefore now the mechanical advantage will be equals to from this equation. So mechanical advantage is load divided by effort. So the load is how much it is? 16 T4 divided by how much is the effort? Effort is T4. So T4 and T4 get cancels. So the mechanical advantage is equals to 16. Or I can write the mechanical advantage is equals to 16 means it is 2 to the power 4. Okay, so 2 to the power 4 is 16. 2 into 2 into 2 into 2 is 16. Okay, so here the 4. So in the figure I see that I have used 4 movable pulleys. So and the power is also raised to the power 4. So therefore generally the mechanical advantage of this kind of system, this system of pulley is equals to given 2 to the power n. Okay, so where n represents the number of movable pulleys. Okay, so that is how we derive the mechanical advantage of this system of pulleys. Now once you have find the mechanical advantage, you can remember the velocity ratio is also given by the same, that is 2 to the power n, where n is the number of movable pulleys. Now if you are asked to find the efficiency, simply the efficiency is equals to 100%, because this divided by this quantity will give me 1, which is the 100%. So this I have done for the 3 pulley system, or sorry 4 movable pulley system. You can try it for 5 and 3. So which is the most asked question in your board examination. Thank you.